Alright, it's a quick rundown of how I solved the ponies please challenge. So, got this page, we need to get our ponies into the club in some disguise. There's some kind of neural network in there, and if we are dumb enough just to put a massive box over the image, it should tell us. It should time out. It should tell us that we snuck something in, but it wasn't a pony, and it was too obvious. So if we grab the code for that, what we can see in here is this thing is a web server. It's got some flag in it we need. It's got two networks trained with slightly different settings by the looks of it. So we got the robust and non-robust one, right? And when we're uploading an image, it's going to take our image in. It's going to say, it's going to ask what each of them think, and the one we want to hit is this set here, where the robust one says, yeah, it's a horse, and the non-robust one says it's not a horse. So the difference between those is basically there's this EPS 005, so some training parameter was ever so slightly different when they were trained. And that implies the non-robust one is less sensitive than it. With that, there's also a hash check, meaning, where is it? If we fail to pass that check, then it doesn't work. So if we just upload a picture of a cow or a dog or something, it's not the original, it's not going to work. So those are the rules. We do have the code and we do have the weights for the network, but only for the non-robust classifier. We don't know what the robust one's doing. And roughly the approach is just set up a classifier locally, start making random changes to it. Kind of approach would be you can make random changes to the image, you can make some kind of geometric pattern that confuses the network, or if you're really, really fancy, you train a network to beat the network, which I didn't do. So what does that actually look like? Well, that's a good question. So here we have a lovely Python file that's kind of hacked together from the source code of that server. Mainly what I've done to it is delete the web server bits. So we set up the non-robust model. We have a function that takes in our image and basically does the same thing. Just gets it through the same checks, and we're checking for the hash difference less than hash difference. You'll notice I've actually tuned that down a bit. And we want the non-robust classifier to say it's not a horse. We can ignore all these are just utility functions, don't need any of that. And then we're on the first interesting bit here, is the get prediction. So we throw an image in, that transforms it into, I think, a tensor or something. And the outputs, that's saying, let's take this image, stick it through the classifier and ask what it is. And we're hoping that it's any one except horse. We don't really care which. And the other thing is this hash difference needs to be low. So if we take a look at this, this is just average hash. So basically, don't change the color of the image overall, is the approach to there. So what we do is we set up our session, we grab the pony, or horse or whatever, and we fetch out the image data and we load it in. I'm saving this to disk, it's not optimal, but it works. And that looks something like this thing. So there is a rather low-res picture of a horse, but that's what the site gave us. So for the hash pass, I'm finding the mean color of the image, and then that's the color that I'm going to draw all over the image with. And I'm just going to iterate until either I failed and got over the hash, or I've managed to convince the thing that it's not a horse. And what I ended up with is drawing random lines all over the image with a width of 3 pixels, which seems to work well enough. It is kind of low skill, but it works. What that looks like is this. So there's a horse, but what we've got is all the extra lines. So inside the network, whenever it looks for an edge or something, it's got these really well-defined edges that it's going to hit. And generally speaking, horses don't look like a pile of sticks, so that's going to confuse the network a bit. So we're going to draw some lines, just iteratively add a line each time until it starts working. We're going to dump that to disk. We're going to say, is it a horse? If it's a horse, we say, yep, cool. If it's gone over the hash, we give up but try anyway. Basically, this is random, so you could try again, but in the web thing, with these counters here, as long as you get one pony into the club every 3 or 4, then you're not going to lose any progress, and you just need to keep going until your win counters over 50 odd. And then we just post it back up, and we grep out the little bit of response text, and that response text will it'll be one of these. So it will either be saying, well, you got something in, but you went too far, and the robust one can't see that it's a horse, right? Or the one we want, which is the robust one says it's a horse, but the non-robust one's broken. And then we don't want these failing conditions, and we definitely don't want this last one, because that's going to reset our counter, and we're going to have to start again from 0 with all our ponies. Alright, so what does that actually look like? Well, I'm just going to do one iteration of it a second. And so if I just drop into my ponies, please. Going to run hackso3 automated. So first thing is that my CUDA is broken. It really doesn't matter for this one. We're just running through a network, so CPU's fine. So we start off, non-robust is saying, yeah, it's a horse, there's nothing there. We start adding lines, and we do get some hash difference. I assume the image hashing is slightly spatially aware, rather than just color. But we keep going, and eventually it's going to say bird. This approach seems to usually say bird or plain, because they have nice big straight edges. And then what we get is success, bounce, I thought your horse was a bird. And that's what we got. And that is quite clearly a bird. Yeah, so that's it. Basically, it's just playing around and messing with the network and seeing what works, but also trying to keep the changes to a minimum. That's it.